Okay, question 48. Whoops, minimize the wrong window there. Question 48 says the table below shows the shoe size and age of 7 boys. Alright, so we have shoe size as our X, it automatically tells us that's our X, and the age is Y. So what I'm going to do is I would immediately go through and I would plug these in my list 1 and these in my list 2. Alright, and it says approximately what percent of the boys' ages is more than 1 year different from the age predicted by the line of best fit for the data. So we need a line of best fit. Anytime you see this phrase, line of best fit, that you need to use that to find something about your set, that means you're going to need to do a linear regression, okay? A linear regression. So once you plug these in your calculator, all right, you would go down to option 4, you go to Stat, Calculate, Linear Regression, all right, and you come up with the equation y equals 1.12 or 1.126x plus about 4.1. Okay, so x is the shoe size, and we're predicting the age based off of the shoe size here. So to find the predicted age for each of these shoe sizes, what I could do is I can go to my y equals and plug that equation in, 1.126x plus 4.1, and then I go to my table and I just look for the different shoe sizes that I was given. So if I scroll down to a shoe size of 6 in my y on my table, now that I've plugged this equation in, I'm not looking in stat, I'm looking in my table from doing second graph with the line of best fit. The predicted age here is 10.86, somewhere close to that. And so obviously for another shoe size of 6 you get the same predicted age. Alright. For Patrick, the shoe size of 7, his predicted age was 11.98. Okay, so really close to 12. Bobby's predicted age was 13.11. Okay. Dylan had a shoe size of 9. That has a predicted age of 14.23. Mike has a shoe size of 10. His predicted age was 15.36. And finally, Jonathan had a shoe size of 12. His predicted age, based off of our line of best fit, was 17.61. Okay? So these are the predicted ages for each of the shoe sizes. Now it says, what percent of the boys' ages is more than 1 year different from the age predicted by the line of best fit? So let's figure out which ones were more than 1 year different. Okay? Tyrone's actual age was 9. His predicted age was 10.86. So if I take the predicted minus this age, 10.86, and I could plug this in my calculator, minus 9, that gives me 1.86. That's more than 1. Okay? So Tyrone was more than 1 year different. Alright? Marcel, his predicted age was 10.86. His actual age was 11. That's just a few tenths, not even a couple tenths off. That's like 0.14 different. Okay? So he was a little older than predicted, but it was within 1 year. So Marcel doesn't count. Now Patrick, his predicted age was a little less than 12. He was actually 15. So his is more than 1 year off as well. Bobby, same thing. Predicted age was 13. His actual age was 11. Okay, so that basically we're saying that his foot is actually probably bigger than we predict, or than we would expect, because he has basically the foot of a 13-year-old, but he's only 11. So that means his feet are a little bit larger than we would expect. Okay, Dylan, actual age of 15. His predicted age was about 14.2. So that's within 1. So Dylan doesn't work. Mike also doesn't work. 15.36 is less than 1 away from 16. Same thing for Jonathan. So out of the 7 boys, 3 out of the 7 were more than 1 year different. So to find the percentage that 3/7 is equal to, we take and plug in our calculator 3 divided by 7. Now, just as a review of old division, working out division by hand, let's try 3 divided by 7. Obviously 7 can't go into 3, so we put a 0, but we put a decimal here and write another 0, and 7 will go into 30 4 times. Okay, so we put the decimal and put a 0 and bring that decimal up, and then we realize 7 goes into 30 4 times. Alright, so I multiply this out. 4 times 7 is 28. Subtract that, and I bring down a 2. Okay, Put another 0 here. Bring that 0 down. 7 goes into 22 times. 2 times 7 is 14. Alright. And if I subtract that, I'm going to have to start writing it over here. I get 6. I would have another 0 that I would bring down. And I would figure out how many times does 7 go into 60. Well, 7 goes into 60 8 times. Right? 8 times 7 is 56. Subtract that, you get 4. We would have had another 0 here that we bring down. 7 goes into 40, and we would just keep going, okay, over and over and over. But 0.4285, that is really close to which of these percents? The answer would be C, 43%. Okay? And if you have a calculator, you could just plug in 3 divided by 7, and you'll get a long decimal that's really close to 43%. All right? So the answer is C.